So this is the third section. Again, it's a smaller section compared to the liver. I apologise for the size of that, but the liver is obviously an important organ in the body, as is the pancreas and gallbladder, but obviously a little bit less complicated. So this section is looking at the pancreas. There's a number of different learning objectives about the pancreas, which I'll let you look at in your own time. So the pancreas, I'm sure you know the anatomy of by now. It has a head region, it has a neck, and then it has a tail which comes away. And of course the pancreas is composed of two components. It's composed of an endocrine section in the form of islets of Langerhans, and it's composed of an exocrine component, which is the largest of the components, which produce a number of enzymes which are released via these ducts. These large ducts and combines with the common hepatic duct or bile-duct to release the secretions into the small intestine. So here we've got a section of the pancreas. We can see the big islet of Langerhans in the middle here, and of course the islet contains alpha, beta, delta cells and things like that, secreting hormones such as glucagon and insulin involved in glucose metabolism. Out here we have all of these rings of cells. These are our acini, exocrine acini, containing cells which are producing enzymes which are released into the small intestine. Remembering the pancreas is a serous-only gland, but obviously in comparison to the parotid gland, the parotid gland doesn't contain islets of Langerhans. And one thing that the pancreas doesn't contain are striated ducts. So striated ducts are salivary gland only, and the pancreas contains the islets of Langerhans. So here we've got a number of these secretory acini. These cells, of course, are characterized by basally located basophilia because of the basal rough endoplasmic reticulum, and then the apical portions of the cells have the zymogen granules, which are the proenzymes before they're activated. And very similar in structure to like the chief cells in the gastric glands, so typical sort of protein-producing appearance. So here's a electron micrograph of some of these cells. Again, we've got a round, basally located nucleus, lots of basal rough endoplasmic reticulum, which would have accounted for the basal basophilia. And then the apical portion of the cytoplasm is taken up by these electron-dense zymogen granules. So they contain proenzymes, inactive enzymes, which are only activated once they're out in the lumen of the small intestine. Now, something else unique to the pancreas compared to the salivary glands, the fact that unlike in the pancreas where we have intercalated ducts running from the secretory acini outwards, in the pancreas these intercalated duct cells extend all the way down into the acinus. And these are known as intercalated duct cells or centroacinar cells. Centroacinar makes it a bit easier to remember because they're in the middle of the acinus. So here we have our ring of secretory cells. Here's our acinar cells with our zymogen granules and the basal basophilia. And then in the middle here we've got our centroacinar cells. Now, interestingly, they both contribute to pancreatic juice. So the acinar cells have receptors for CCK, because if you remember, CCK is being released in response to fatty acids and amino acids coming from the stomach. So that suggests to the pancreas, okay, it's time for digestion, let's release all our enzymes to break down all those food products. So CCK receptors are found on the acinar cells, causes them to undergo exocytosis, release all those proenzymes into the lumen, and then they're carried out into the small intestine. The duct cells, however, they contain receptors for secretin. And so when secretin is released, just like when secretin is released for the liver, these duct cells release bicarbonate into the pancreatic juice. So secretin works both at the liver level of the liver and in the level of the pancreas. CCK also works at the level of the liver and also the gallbladder and the level of the pancreas in the form of the acinar cells. So they're not always that easy to see, however. So can be a bit difficult to visualize. So what you want to be looking for to identify central acinar cells are sort of almost squamous appearance to the nuclei. So there's I'll magnify this view here. So here we have a ring of acinar cells, basal basophilia, a little bit of apical acidophilia here, and we've got these flattened nuclei. You can see them right next to the acinar cells. So this is our central acinar cells surrounding our acinar cells. So then in summary, here we got our duodenum, which has our enteroendocrine cells, one which secretes cholecystokinin, one which secretes secretin. Cholecystokinin is released in response to the fatty acids and the amino acids, and the secretin is released in response to the drop in pH. The secretin has receptors. There's receptors for secretin on the intercalated duct cells or the centroacinar cells, and they release bicarbonate into the secretion, pancreatic juice, and cholecystokinin, the acinar cells have receptors for those, stimulating them to exocytose their proenzymes into the lumen, into pancreatic juice, where they're eventually activated in the lumen of the small intestine. So that's it for section 3. Again, there'll be a couple of multiple choice questions which you can test yourself on. So that's it for the lecture. Thanks for your time. I apologise once again for not being able to be present at the lecture. I hope this is in some way makes up for that. Thank you. Bye.